Good day everyone. Today we are going to start chapter 2, that is Electrochemistry of class 12. We are going to complete this chapter with a detailed explanation and ncert reading and going to solve few questions. So first, let us try to understand what is electrochemistry. So basically, it is a branch that deals with the study of production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to carry out the non-spontaneous transformations. So a large number of systems such as energy converter and storage, fuel cells, battery systems, industrial synthesis and production of various chemicals involves these electrochemical methods. So electrochemistry brings advancement by making reactions energy efficient as well as eco-friendly. Therefore, it is very important to study about electrochemistry. So first, let us try to understand what are redox reactions. So redox reactions are those reactions where we see both the loss of electrons and the gain of electrons. Losing of electrons is called oxidation, gain of electrons is called reduction. So redox reactions will involve both oxidation and reduction. And these both reactions are complementary and occur side by side. Let's take an example. So here we have H2S plus Cl2 will give rise to S plus 2HCl. So here this is going to lose its electrons, means oxidation will happen, while the Cl2 will gain electrons, that means reduction is happening. So here both oxidation and reduction are happening, so it is a redox reaction. So here in these reactions we can observe the transfer of electrons, and therefore it will be a cause to generate electricity. Therefore redox reactions will set up the basis for electrochemical cells. So now let us understand what is an electrochemical cell. So it is a device in which the chemical energy of the redox reactions is converted into electrical energy, and in the electrolytic cell is a device in which the electrical energy is converted into chemical energy. So they function vice versa, and this is the reaction. And the most common electrochemical cell is the galvanic cell or the voltaic cell, and a galvanic cell is the modified form of Daniell cell. So this is the following reaction for a Daniell cell with an electric potential of 1.1 volt, and this is the concentration of the used ions. So we know that galvanic cells are the electrochemical cells which convert the chemical energy of a spontaneous redox reaction into electrical energy. So in these cells we basically will place an electrode in a solution of its own salt. So suppose if we place Zn electrode, then this salt will also be belonging to zinc, such as zinc sulfate or anything like that. And this combination is called a half cell. Or a redox couple. So in a half cell, either reduction can happen or oxidation can happen. So oxidation will occur at anode, that is, it is the source of negative electrons, while reduction occurs at the cathode and it is the receiver and it will become positive. So you have to always remember, oxidation will occur at anode and reduction will occur at cathode. And these processes of oxidation and reduction result in the formation of potential difference between the two half cells and hence generate electricity. So now we'll study about Daniell cell. So this cell consists of two metals or electrodes, that is zinc and copper, and the zinc rod will be mixed or placed in the zinc sulfate solution and the copper rod will be placed in the copper sulfate. So these both make up an half cell and this will make up another half cell, and these two solutions are connected by electric current and a salt bridge is placed. So here we have the zinc electrode and this is the solution of salt of zinc. Same here, the copper and the salt of copper, and electricity is connected and we have a voltmeter, and the two half cells are connected by a voltmeter and a switch externally, and the electrolytes are connected internally with a salt bridge, and both the electrodes will be dipped in same electrolytic situation. In such case, salt bridge is not required. So if we place both the rods in the same solution, then salt bridge is not required. Now we will see the half cell reactions. So here basically we can understand that this is negative and this is positive. That means this functions as a oxidation half cell while this functions as a reduction half cell. This is anode and this is cathode, and therefore electrons will flow from here, that is it will release the electrons while this will receive the electrons. So zinc is on the oxidation side, it means it will lose the electrons, so oxidation is taking place, so this will be the reaction, that is it is losing 2 electrons, while copper will receive these 2 electrons and it will undergo reduction. So when we combine both these reactions, we can get this reaction by cancelling both the electrons. Now we will study what will happen if we apply an external voltage to this cell. So in case 1, that is when the electric potential is lower than 1.1 volt. So we know that this Daniell cell will produce electric potential of 1.1 volt. So if we apply an external voltage which is lower than 1.1 volt, then the electrons will as usual flow from the zinc rod to the copper rod, and hence the current will flow from copper to zinc in the opposite way of the electrons, and hence there will be no change because in the same way here the copper will get deposited. And then in the case 2, when the external voltage is applied equal to 1.1 volt, then the cell reaction will stop and there is no flow of electrons and therefore no flow of electricity. In the case 3, when the external potential is more than 1.1 volt, then the reactions will get reversed, which also reverses the polarity of the electrodes. So in that case it will become an electrolytic cell. So electrochemical cell will become electrolytic cell, and now the flow of electrons will be from copper to zinc, and therefore zinc will get deposited while copper will be depleted. It works quite opposite to the electrochemical cell. So now we will understand what is a salt bridge. So it is basically a U-shaped glass tube containing electrolytes such as KCl, KNO, NH4Cl mixed in some kind of gel like gelatin or agar-agar. It plays a very important role in working of an electrochemical cell and it completes the circuit and maintains the electrical neutrality of the solutions in each of the respective half cells. So meter bridge will be the connection between the two half cells and will maintain the neutrality in between. So basically, the salt bridge is added in this Daniell cell was a modified form of the original galvanic cell, because the electricity flow stops after some time as the positive charge accumulates at the oxidation half cell and the reduction negative at the reduction half cell, and which balance the redox free energy and hence stops the redox reactions in our original galvanic cell. But in the modified galvanic cell, we can find that the salt bridge is present and it provides the anions and cations to the respective half cells and thus maintain the neutrality of the half cells. So salt bridge is very important in this whole functioning of electrochemical cell, so that it will not stop and continue to happen. Now let us study some important terms related to a cell. So first we'll study about electrode potential. So what is electrode potential? It is the potential difference which is developed between electrode and electrolyte. That means when we dip an electrode in electrolyte, then there will be some potential difference which will be generated, which is known as electrode potential. So electrode potential can be of two, that is oxidation potential and reduction potential. So we have both the cells, that is oxidation half cell and reduction half cell. So here in the oxidation half cell we have oxidation potential, and the reduction half cell we have reduction potential. Moving to the next one, that is cell potential. So the cell potential is the potential difference between two electrodes, that is the two half cells, and the formula is E naught of cell is equal to E naught of cathode minus E naught of anode. Here we can understand that cathode reduction will occur, anode oxidation will occur. So it is the difference between the standard reduction potential and the standard oxidation potential. That means we have the difference between the standard reduction potential of cathode and the standard reduction potential of anode, and it depends on the following factors, that is nature of the metal and its ions, concentration of electrolytes used, and the heat which is provided. Now cell potential is the same as electromotive force, that is EMF, when no current will flow through it. This is a very important point to note. Now we'll study how we'll represent what is a cell representation. So it has basically three steps. First, we will write down the reaction which is happening, and then we'll write down the half cell reaction. So we'll break down this reaction into two reactions, oxidation reaction and reduction reaction, and then we will write the cell representation. So for this, how we will start? So remember the word lone. Here in the left we have oxidation in the anode side and it is negative. Remember these, in the left we have oxidation which is anode and it is negative. I'll explain the cell representation with this example in a while. First we'll complete what is the standard electrode potential. So under certain conditions, the electrode potential under certain conditions, that is these are the conditions. That means the concentration of the species should be this much and the pressure should be this much, and it should be under 25 degrees Celsius. And according to IUPAC, the standard reduction potential is only considered as the standard electrode potential. So here the standard reduction potential is also equal to standard oxidation potential, but the signs will be reversed. Now we will understand what is the measurement of electrode potential. So how do we actually calculate what is the standard reduction potential of any metal? So it will be done with the help of standard hydrogen electrode. It is represented in this way. and the reaction will occur like this. So here we can observe that this basically consists of a platinum electrode which is placed or coated with platinum black and dipped in a solution of H plus ions, and pure H2 gas is sent with high pressure. So here the electrode has zero potential at all the temperatures. So this will have zero potential at all the temperatures. So you can easily find out the potential of the other cells which we are placing in connection with this half cell. So we can measure the EMF by combining this standard hydrogen electrode of the anode with an other half cell of cathode, resulting in the standard reduction potential of the other half cell, that is the cathode. So in this manner we can study the half cells which can be measured easily. So here this is the reaction in which we already know that the She electrode potential is 0, so we can easily find out the standard reduction potential of our required half cell. So here this is a cell in which we know that this will be 0, so you can easily find out, and we found out that 0.34 volt will be the EMF of this half cell. In the same way, for zinc we have found it to be minus 0.76. So here we can simply understand that the positive value of the electrode half cell in the first case indicates that Cu2 plus ions get reduced more easily than H plus ions. So hydrogen gas can reduce copper under certain conditions, and thus copper will not mix up in HCl. So this will be taken in the oxidation half cell, and this will be taken in the reduction half cell, and the overall reaction will be like this. And we can calculate the EMF, that is what is taken in the right side minus of what is taken in the left side. So we can get the electrode potential to be 1.10 volt. So we have some inert electrodes. Those are some metals like platinum or gold are used as inert electrodes. They do not actually participate in the reaction but provide their surface for oxidation or reduction reactions and for the conduction of electrons. So here also the platinum is actually inert electrode. So it will not actually perform the reaction but help us to actually find out the reduction potentials of other half cells. Now we'll see how actually we will write the cell reaction. So here we can observe that there is a loss of electrons. So this will undergo oxidation, and here there is a gain of electrons, that means Fe will undergo reduction. So oxidation will be written in the left side and reduction will be written in the right side, and these both will be separated with a double line, that means it is a salt bridge. So here Cr and Cr3 plus, so we'll write down like this, and Fe2 plus becomes Fe. So this will become the whole cell representation. Now we will do a quick reading to the NCERT. So here the chapter will start with the introduction of electrochemistry. It is the study of production of electricity from energy released during spontaneous reactions and the use of electrochemistry to bring out the non-spontaneous chemical transformations. And these are the importance of electrochemistry in this whole paragraph. And then they have told us what is an galvanic cell, voltaic cell, electrolytic cell, and the working of the electrochemical cells, and what will happen if we provide an external voltage. So here if the voltage is equal to the internal voltage, then the reaction will happen the same. It will stop, and if it is less, then the reaction will happen the same, but if it's more, then it will become an electrolytic cell. And then they've told us the working of the galvanic cell and the half cells or redox couples, reduction potential, electrode potential, and how do we measure electrode potential, that is using the standard hydrogen electrode. And these all are done, and this is completely done, and there are some in-text questions provided for you. So tomorrow we'll start with the calculation from the Nernst equation. Thank you so much for watching. Stay tuned for the next parts of this chapter. Thank you.